Fairy tales are all about princesses, and there are plenty of them. I'm Filip, a PhD student in molecular life sciences, and I chose to study Snow White for my thesis. What makes Snow White unique is that she ate a poisonous apple, but then came back to life. So why am I talking to you about her? Because Snow White, being poisoned by the apple, is exactly what happens to bacteria cells when treated with antibiotics. Most of them instantaneously die. However, less than 1% of the population of millions of cells in a colony come back to life. This phenomena is termed bacterial persistence, or the Snow White effect, as I like to call it. Once the antibiotic is removed, just like Snow White with the poison apple, persistent cells wake up. Persisters can acquire superpowers that make antibiotics ineffective against the whole population, not just the 1% I mentioned earlier. A study published in the reputable journal Lancet in January this year attributes that in 2019 alone, 5 million deaths around the globe are due to bacterial infections. Clearly, persistence is such a problem to the human health. So what is it that we can do about that? In my PhD thesis, I tried to figure out how and why did Snow White come back to life? That is, how does bacterial persistence occur? To do this, I look at the many tiny hearts that bacteria have, the ribosomes, which are targets for most of the antibiotics on the market. I put special color tag on the ribosomes, put them under the microscope, and measure the effects that the various antibiotics have on the number and activity in persistent cells. This is just a mere introduction to the huge fairy tale termed antimicrobial resistance, or AMR. To combat this, we need effective antibiotics, rapid diagnostics, correct stewardship, access, and fair distribution to it. My project contributes in two directions. I address fundamental questions of antibiotic interactions in living bacteria, thus filling in the knowledge gap of what's going on in bacterial cells in real time. Moreover, this is a platform for high-throughput screening of novel antibiotics, thus providing the tools for drug discovery. My goal is to give a touch of happy ending to the AMR fairy tale.